At the southernmost tip of Spain lies Point Meroy, and directly across the water, just 13 kilometers away, is Point Sires in Morocco. This narrow yet significant stretch of water, known as the Strait of Gibraltar, connects the vast Atlantic Ocean with the Mediterranean Sea. Despite its modest width of 13 kilometers at the narrowest point and a length of 57 kilometers, no bridge or tunnel has ever spanned this critical gap. Imagine a bridge stretching over the strait, a distance comparable to that between San Francisco and Oakland in the United States. The waters here plunge to depths of around 365 meters, presenting a formidable challenge to any construction project that dares to span it. Over the decades, numerous ambitious proposals have emerged, each promising to link these two continents in a transformative way. So, with modern technology and countless successful megastructures around the world, why does this modest span remain unconquered? The Strait of Gibraltar is a crucial juncture where the Mediterranean Sea meets the Atlantic Ocean. It's one of the busiest maritime routes in the world, with over 100,000 ships passing through it every year, making it a vital artery for global trade. The idea of connecting these two continents has fascinated engineers and visionaries for decades because the potential economic benefits are staggering: streamlined trade, tourism boosts, and a powerful symbol of unity. Yet, despite numerous proposals and advances in technology, this grand project remains unfulfilled. Historically, the concept of a transport link between Spain and Morocco dates back to ancient times. The Greeks and Romans called the strait the Pillars of Hercules, a mythical boundary marking the edge of the known world. Fast forward to the 20th century. The first serious plans emerged in the 1930s with proposals ranging from bridges to underwater tunnels. But each time, the plans were shelved due to technological limitations, political discord, or financial constraints. In the 1970s, the Eurome transport project rekindled hopes of building a link, but once again, it fell through. Each subsequent decade saw new proposals, from floating bridges to underwater tunnels. Some were visionary, like the idea of a bridge supported by giant pylons or a tunnel resting on the seabed, but all faced insurmountable obstacles. So why hasn't this monumental project moved forward? What are the real barriers that prevent Europe and Africa from being connected by road or rail? First, let's tackle the depth of the Strait of Gibraltar. At its narrowest point, the water is around 365 meters deep. Imagine trying to build a bridge over a chasm that deep. The foundations would need to be massive to support such a structure. Engineers would have to sink pylons deep into the seabed, which isn't as simple as it sounds. The seabed in the strait is composed of unstable quaternary clay channels. These soft, shifting sediments make it extremely difficult to secure anything solid. Pylons would have to penetrate deep into the seabed, potentially hundreds of meters, to find stable ground. This process is not only technically challenging but also time-consuming and expensive. Next, consider the powerful currents. The Strait of Gibraltar acts as a natural funnel between the Atlantic Ocean and the Mediterranean Sea. Water flows in from the Atlantic at a tremendous rate, replenishing the Mediterranean, which loses water to evaporation. These currents, along with tides, make any underwater construction incredibly challenging. Workers would face constant movement, making precise work nearly impossible. Imagine trying to perform delicate construction tasks while the water around you is moving rapidly. This would require highly specialized equipment and techniques to stabilize the work environment, adding further complexity to the project. Even if we could stabilize the seabed and manage the currents, the next issue is the shipping lanes. Over 100,000 ships pass through the strait each year. These are not small vessels, we're talking about massive cargo ships and oil tankers. A bridge would need to be high enough to allow these giants to pass underneath, which means a height of at least 100 meters above the water to accommodate the largest ships. This would make the bridge one of the tallest ever constructed, presenting its own set of engineering challenges. Additionally, the design would need to ensure that the bridge doesn't interfere with the complex navigation of ships through the narrow strait. The structure must be resilient enough to withstand potential collisions and constant vibrations from passing ships. Adding to the complexity is the fact that the Strait of Gibraltar lies on a tectonic plate boundary. The Eurasian and African plates meet right under the strait. This area is prone to earthquakes, which pose a significant risk to any large-scale construction. The 1755 Lisbon earthquake, which had an estimated magnitude of 8.5 to 9.0, caused widespread destruction across the region. Any bridge or tunnel would need to be designed to withstand such seismic activity, adding further to the engineering challenges and costs. Earthquake-proof structures require advanced materials and design techniques, which are not only expensive but also still developing. And an alternative to a bridge is a tunnel. This idea has been revisited multiple times over the decades. A tunnel could bypass some of the issues associated with a bridge, such as the need to accommodate ship traffic. However, tunneling under the Strait of Gibraltar is no simple feat either. The Channel Tunnel, which connects the UK and France, spans about 50 kilometers and took 6 years to build. It faced numerous challenges, but the geology of the seabed was relatively stable compared to the Strait of Gibraltar. In contrast, the Strait's seabed is highly unstable, composed of those tricky quaternary clay channels we mentioned earlier. These can shift and buckle under pressure, making traditional tunneling methods problematic. Engineers have considered different tunneling techniques, such as using a submerged floating tunnel. This would involve creating a tube that sits about 100 meters below the water surface, anchored by cables to the seabed. It would avoid some of the seabed instability issues, but would still need to withstand the powerful currents and the risk of collisions with passing ships. In addition to the technical and engineering challenges, there are significant political and financial obstacles that have prevented the construction of a transport link between Europe and Africa. The political relationship between Spain and Morocco is fraught with historical tensions. Disputes over territories, such as Ceuta and Melilla, complicate cooperation. Both nations would need to agree on numerous issues, from construction oversight to revenue sharing. This is no small task given their rocky history. Gibraltar adds another layer of complexity. The UK's control of this strategic point is a contentious issue for Spain. Any project would need to navigate these political waters carefully, ensuring all parties are satisfied. Then there's the financial aspect. Building a bridge or tunnel across the Strait of Gibraltar is an incredibly expensive endeavor. Estimates for such a project range from $5 billion to $20 billion depending on the type and scale of the construction. Funding such a massive project requires significant investment from both governments and possibly international investors. The economic benefits, while potentially substantial, are not guaranteed. Governments would need to see a clear return on investment to commit such large sums of money. Despite these challenges, there are glimmers of hope. Advances in engineering and technology may one day make this project feasible. Political landscapes can change, paving the way for better cooperation. There is even a potential $25 billion plan in place, aiming to bridge the gap. This ambitious project, still in its planning stages, promises to revolutionize travel between Europe and Africa. But as with all grand endeavors, it faces a mountain of challenges before becoming a reality. The dream of connecting Europe and Africa with a bridge or tunnel is an epic tale of ambition, challenges, and potential. Whether or not it becomes a reality remains to be seen. We'd love to hear your thoughts on this one. Do you think there's a solution to this complex construction problem? If you enjoyed this video, don't forget to like, subscribe, comment, and turn on notifications for more fascinating insights. Thanks for watching.